In this video, we're going to be learning how to find square root of a non-perfect square number. This is a continuation of my previous video on finding square root of a perfect squared number. Now remember, as I told in my previous video, most of the numbers ending in 0, 1, 4, 6, 9 or 5 usually are perfect square numbers. Not all ending in these digits are square numbers, but most of them. If you find any number ending in digits other than these numbers, they are definitely going to be non-perfect square numbers. So we will be learning how to do that in this video. The link to my previous video is in the description, so if you haven't checked that out already, I really encourage you to do that. So let us begin. Before doing that, let me take an example. Say root of 46. Now we know root of 49, we know root of 36 because these are all perfect square numbers. You see that these are ending in digits 9 and 6 just as I told here. So we can easily find the roots of these numbers. For non-perfect square numbers, we will have to find a perfect square number and somehow correlate this with this one. Like for example, we can write root of 46 as root of 49 minus 3. This will give us root of 46. So this is what we are going to be doing throughout the video. Find a perfect square number and correlate the given number somehow in the terms of plus or minus. You gotta either be plus or minus here. So there is a very small formula that I want to give here. If you have been given any number, first of all, you're going to bring it in the form of root of x plus or minus y. Here x will be a perfect square and y can be anything, perfect or non-perfect square. So you really don't have to worry, but what we really need to be considering here is that the first term x should be a perfect square. So the formula to this is root of x plus or minus y upon 2 root x. Remember, the plus or minus here totally depends upon plus or minus here. If it is plus here, it's going to be plus here. If it's minus here, it's going to be minus here. So let's take some examples to understand this better. Say we're taking the example of root of 7. We know that we can split root of 7 as root of 9 minus 2 because 9 is a perfect square. So we're going to be taking the root of the first number. So root of 9 will be 3. Since it is minus here, you're going to keep minus. You're just going to keep the second term as it is, divided by 2 times root of x. So you just double this number and write it here. So it's 3 minus 2 by 6. When you simplify it further, you get 3 minus 1 upon 3. All you got to do now is simplify this, which will be 8 upon 3. You have to just simplify this and you're going to get your final answer. The final answer turns out to be 2.66. Now this number is purely an approximation. You will definitely find accuracy up to first decimal places. So even in exams, if it has been asked, they will usually be considering up to first accuracy level itself. So this is the fastest method. Even if there are other methods, you can use this method to check your answer. So the only time consuming step here is to simplify this term 3 minus 1 upon 3. It is a whole number and a fraction, so you will have to take LCM. What I have done here is, for those of you who didn't understand, it is 3 minus 1 upon 3. So you take LCM, you're going to multiply this number by 3 because it's 1. So what you get is 9 minus 1 by 3, which is equals to 8 by 3. So I simply skip these two steps and directly wrote 8 by 3. So our second example is going to be root of 15. So we know that root of 15 is closest to root of 16, which is a whole number. Root of 16 is 4, as we know. So we're going to be writing 15 as 16 minus 1. So you see that root of 16 will be 4 because we need root of x, and x is going to be a perfect square. Minus, you're going to just keep the second term as it is, minus 1 upon, you're going to double this term. So double of 4 is going to be 8. So it is 4 minus 1 by 8, which is equals to 31 by 8. On further simplification, you're going to get it as 3.87. Now remember, if you want to master at this formula, you will have to keep practicing, and I'm sure that finding the square root of any non-perfect square will be really simple to you. So let us take another example. Our next example is root of 13. Usually when we see digits such as these, we can solve it, but let's try to easily solve it. Now, to solve this problem, let me give you two different ways. So it can be 16 minus 3 because 16 is a perfect square of 4, or you can also write it as 9 plus 4. So no matter which way you solve it with, you're going to get the same answer. So I'm going to just go with 9, root of 9 plus 4. So root of 9 will be 3. There is a plus sign, so keep the plus sign here. Then you keep 4 as it is and double this number. So you're going to get double of 3 is 6. When you solve it, you get 2 by 3. Now remember to solve it as much as possible. It will only make your work much easier. So 3 3 is a 9 plus 2 will be 11 by 3, which is approximately equal to 3.6. So my next example is 101. We're supposed to find the square root. So it is going to be 100 plus 1. Square root of 100, that is the square root of x term, is going to be 10 plus the same sign as it is under the root. You keep the second term y as it is and double the square root of x. So double of 10 will be 20. So when you solve it, you're going to get 200 plus 1, that is going to be 201 divided by 20. Now here I'd really like to give you a simple trick. When you have a multiple of 10 in the denominator, you see that it is the second multiple of 10. So what you do is you divide by 2 here and 2 here. It's going to be 100.5. You see, double of 100.5 will be 201. Once you have this, you just got to take the decimal point one place towards the left. So it's going to be 10.05. So this is going to be our final answer. This comes really handy when you have no calculator and you're in dire need of calculating the square root of something. Now let us find square root of 150. We see that 150 is closest to root of 144 plus 6. 144 square root is 12. So you're going to take this square root 12 plus, keep this as it is, 6, and double 12. Double of 12 will be 24. 6 1s are 6, 6 4s are 24. So 1/4 is equals to 0.25. So it is going to be 12 plus 0.25, which is equal to 12.25. So this is our answer. Our next example is 440. So you see I've got the formula off the screen. We'll try to solve it without using the formula. Our first step is to divide 440 in such a way that you get a perfect square. So 400 is a perfect square plus 40. Now you're going to find the square root of first number. Square root of 400 is 20. Keep the second number as it is and double the first number. Double of 20 will be 40 itself. So 41. Oh, we got a pretty simple one. So 20 plus 1 will be 21. Now here you're seeing that we got a perfect number, a perfect whole number, but the number we were dealing initially was not a perfect square. So what you do in such cases is you subtract 1 from the answer that you got. So 21 minus 1 will be 20, and you just write 9. 20.9 will be your final answer. Now this kind of error occurs because of approximation. So if you draw your calculator out and check the square root of 440, you'll get something around 20.976. So you see how much close 20.976 is to 21, and that's why we got this kind of error. So all you got to do is subtract 1 from this and add 0.9 to it. So it's going to be 20.9. You do not have to worry about these digits. Usually it's added up to a single decimal place. So square root of 440 is 20.9. So our last example here is root of 99. Now this is going to be really easy for you because root of 99 is nothing but 100 minus 1. Take the root of first number. Since it's minus sign minus, keep the second number as it is. 1 upon 20. You gotta double this number. So 1/20th of a number is nothing but 0.05. So it's 10 minus 0.05, which is equals to 9.95.